So CalcPlot3D has a limited ability to plot cylindrical coordinates. So that's what this video is about, is cylindrical coordinates. So here I've got this function I don't need right now, but under cylindrical coordinates, the way we plot that is here. You can see the r, theta, and z. Remember, that's our three variables. But you see it's limited because it only allows me to plot if I have the r solved for. If I have a cylindrical equation with the theta or the z and I can't solve for the r, but it's solved for theta or z, then I won't be able to get a good rendition here. But if you can solve for r, you can plot the pieces in terms of r equal theta and z. So let's just click on it. And so this one's plotting our very basic one. We know that this is going to give me a cylinder because r is equal to constant 2. Theta can be anything, z can be anything. So if I just click that on, you can see it gives me a cylinder based on the intervals that are given. So theta is going from 0 to 2 pi. That's spinning it around, but notice the z is going from 0 to pi. So it's starting at 0 and going up to pi, which is 3.14. If you want to change that, maybe you want to go from -1 to 1, then it'll give you a little, only the part of the cylinder. So you can adjust the limits here. Here I'm not sure. I was putting another theta. So if I want to actually write an equation with some thetas in it, that's how you do the variables for theta. So for example, maybe I want to plot cosine theta. So then I would click on, get that out of the way. Oops, doesn't like that. Cosine theta. It's not letting me put it in there. Okay, there it went. It's giving me an error because it thinks I'm trying to plot the thing. There's the graph of r equal cosine theta from -1 to 1 in z direction, 0 to 2 pi. Now, if you don't want to show all of those other points on the axes, that'll have to be corrected up here. So if I, for example, I'm going to go from -1 to 1, I can just put those in, and you can see I can change those to kind of zoom in a little bit more on that graph, changing the scale and those sorts of things as well. So that's kind of the best we can do on cylindrical coordinates. Have to be able to solve for r. But like I said, if you have something that doesn't have the r solved for, you could maybe solve for r, and it might have some pluses or minuses, and then you'd have to come in here. And then the options here, this just saying if it's not fine enough, if it looks blocky, you can change the number of steps, meaning it'll make it a finer graph. And then these are pretty similar. You can do constant color wireframe and those sorts of things like we've done with some of the other graphs. So it's limited, but it'll actually draw the ones that we typically will run into in this class. So it's worth coming in and exploring it, especially in homework. If you're drawing a graph, you think you got it right by hand, then you come over here and check yourself. So we'll move on to the next graph, which is related to this, which is going to be spherical coordinates.